Once again, this is Mario with MIA Microflight, and this is the latest go-kart that I've been working on. I modified some of the dimensions and some of the components here. This is what I had before, and this was what I was shooting for with the hoverboard at the front, and I made those brackets, welded those assemblies there so that I can attach the hoverboard to the front end and steer this just like foot pedals via the sitting down, just as you would a go-kart. The problem that I ran into is that when you steer the hoverboard on a pivot point, is you see it here, and you're doing it with your legs, one leg is going to have to extend way out here while the other one has to retract in order to establish a very tight turn. And so that was a little bit uncomfortable to do that and unsafe, mainly. I'm concerned with safety when it comes to these things. If your foot slips, from there, you run into a situation where you might hit the throttle on the one side, and the car is going to go sideways, as it did to me in one instance while I was test driving, this particular setup here. You can see that in one of my videos where I'm running into the when I went to the schoolyard, just to do a test drive, and as I was coming out of the, although it was late at night, and I do these things when there's hardly any traffic. There was a car that was coming on the opposite side of the side that I was at, and I ended up going off the sidewalk, and my foot slipped, and I kind of, this jiggle, and it's just unsafe. I mean, I was safe there, but it. It could have been, I could have hit the throttle, and then, I could have fallen off the cart. So it's for safety reasons. I just don't think that this is a good option right here. Even though there are so many videos of people putting lawn chairs on top of these structures, that they and even there's a company that sells these foot pedals, that you can assemble, to mount it on your hoverboard. As I found out later on after I had done my foot pedals, from a logical standpoint of trying to do exactly what you see here. This was my original drawing, and then I did this, and then I went online and I stumbled on this other video where some company, I guess, they were selling these things with the pedals. Excuse me. So I decided to not go this route here and just go back to the original go-kart setup here. And as you can see, I have a picture of a go-kart here. Let me just switch this over here. So that we can see this. Let's see if I can do a flip here. No, I can't do a flip. I have to go this route here. So you can see it's more in line with a go-kart setup here. As far as the steering is concerned, you can see how the steering is done on this particular go-kart here. And I have this as reference, not that I want to replicate exactly the same thing that's here, because number one, I'm not fond. Let me put it this way: I'm not fond of go-karts that are that are not done symmetrical. This is symmetrical to a certain degree, but it's got these extra bars here, and I think they do this, to mount the motor on the side of the go-kart and to balance it with the driver on the others on the side. So I don't particularly like that setup, and it throws me off when I see go-karts done that way. With the engines on the side. I think the engines should be at the back, in line with the pilot, with the rider, with the driver, and everything should be symmetrical on from the center line of the go-kart. So I don't particularly like these cars that have these double bars and this weird geometry on the side here. So, but I do have this one is a reference here as far as dimensions. What that I use as reference, not so much. There are no given dimensions here, so I have to kind of scale it down scale it out or scale it up, and kind of size it to where I think it's right. So it's all a trial and error thing, and because I've done already a few of these go-karts, I've gotten a good sense of proportions. I mean, I already had a good sense of proportions, but it's every one that I do after the my first few ones, it gets even better because it's just acquired experience, and you learn where to put things and what works better than some other things. As you can see here, when I say what works better than some other things, I am trying to replicate right here in this particular area the support that you see over here on this go-kart here. As you can see, this is supported on this plate that has this tube here where this inserts, and I'm pretty sure this has some kind of a lock nut or something, or a collar at the bottom here to retain it. And then they retain the steering column at 2 points, this point right here, and then this other point over here where this red block, support block is at. And this is, they also support that block via these two bars right here. They're kind of interesting geometry there. And so I'm going to be doing something similar in this particular one. I've gotten really creative in some other builds where I'm using the actual maker pipe connectors. This is done with EMT tubing and maker pipe connectors, by the way, as if it's not obvious, in my drawing here, for those that know the shape of maker pipe connectors. And I've done, like I said, this with ball bearings and all kinds of other ways to attach this bar right here. This is my steering, basically my steering bar, and so this has to go through a. I've done stuff like this with Delrin shoulder washers, where the actual tubing rides inside the shoulder washer. This is it's 3/4 EMT tubing, but the actual diameter, outside diameter, is actually like closer to 1 inch, 0.9475 or something like that, I think. And so I've done this with Delrin washers on a similar setup to this shoulder washer over here, shoulder washer here, a stop collar at the top, at the bottom, and so that gets retained there. And at the bottom, I've also done, with Delrin shoulder washers, is my bearing support, if you will, for this axle, which not axle, for this shaft, steering shaft, that also has this control arm for the linkages here. Now this is not quite finished. This is CAD drawing that I'm still working on, and so, but you get the idea here. Here are the linkages here, and they're just I just put them in line here with the C brackets, spindles. But the idea is to attach that to this arm right here, and this is also done with the empty tubing pressed at the end, just like these are done, pressed at the ends, except that this one's not rounded at the bottom here. But eventually I'll round this off, just to make it nicer on the real part, and connect the tie rods to that. So this is my actually my arm, my 90-degree arm that does the control to the steering here. This right here, as I was saying, I want to make it very similar to this go-kart here, to this setup right here, that part right there. And so what I'm going to be doing is I'm just going to be doing as most of the old-fashioned go-karts were done, I believe. It's just a welded piece of tubing, 90 degrees with this 90 degrees with this support tube at the bottom here, 90 degrees and a little bit tilted upward, so that it mates, so that this comes in line with that tube. I'm just going to weld that ring, if you will, to this tube right here, so that inserts. So that ring will have to be about an inch in inside diameter, so that this is able to smoothly pivot inside that ring, and that ring will be welded. That ring will be welded to this section right here. So it'll have a ring here. I don't have that drawn here, but if we if we can imagine. Let me see if I can just quickly draw what I'm trying to do here. No, it's I need my other hand to do this. I'm working my camera with one hand, but I think I think you get the picture here, as I just explained here. So that's what I'm going to be doing today. I'm going to be welding that section there. I'll show where my car is at, my physical real, the real thing, in just a little while here. The other thing I've been doing is I've been trying to make these covers for these wheels here, and so this has been this delta shape geometry here has been a favorite of mine in so many things. If it's something that I employ in my gears that I used to manufacture for the Robin 280 helicopter, the Bumblebee, the Housefly, the Micro series helicopters that I came up with, way before anybody was selling these little palm-sized micro helicopters. And so I did this setup here for my gears, injection molding my own gears. I had to cut this on the molds. So I did this delta shape. This delta shape is rather generic. You'll see that on Mercedes-Benz has the same delta shape. It's not that I'm trying to copy Mercedes-Benz. It's just that I really like this three spoke geometry here. It's just pretty cool, and it also keeps things lightweight when you do this. There are not too many spokes. I've done this also for wheels, for model radio control airplanes. I've done this for so many other things. So I've been playing with that geometry to see if I can go with something like that, or maybe like a button shape cover. And this is just a cover, to cover this hub, this hub section here. This is part of the hub here. This is one half of the hub of these wheels. I just took this, to get dimensions so that I can generate this cover here. So that'll cover right in here, and it'll be supported by as you can see, this has an inside hole here, and it'll be supported by the bolt that comes out through here and the lug nut. There is a spacer between this part right here and the bolt and the lug nut, so that the lug nut is actually putting pressure on the spacer against the hub here, and not so much on this plastic part that I will be 3D printing. So that's where I'm at with that. The shape, like I said, I changed the shape. As you can see here, I went from a almost 6.5 inch distance parallels here. I went to a 12-inch here, and that I had to do because of my bender. My bender can only bend up to a 6-inch radius, or 5.5, something like that. It's my bender, just a Klein bender, for electrical tube bender that I modified, and I showed that in some other videos. How I have that mounted on a solid post where I do my bending of my conduit. It's precise enough to do stuff like this, kind of wing it. It's not a true precision machine by no means, but it does allow me to do to get some pretty decent curves right there. So that I can only establish, like I said, a 6-inch radius. So when you do a 6-inch radius, the maximum you can have as far as the full radius here is 12 inches for a diameter of 12 inches, and so that establishes also this distance from here, from this point right here to that point right there. And so I had to open up these parallels, to that distance, just to keep things very simple. I also did. I also lowered my angles here. These are actually this right here in the model. I haven't done that. I haven't lowered these angles here, but on the real thing, I removed some of these 45s here, and I made them somewhere around 30 here. So this is really compressed. It kind of lowered itself, and that was so that I could attach these wheels directly onto this tube here, and I have to go with a riser tubes as I had before over here. You can see there's a riser tube right here, and the bar sits underneath this connector here. So I didn't want to do that like kind of sort of like that, and so I wanted to make it more. Here's another one that I did. With to use the hoverboard at the back with the control handles, just like those attachments that you use, but except that this is done for much bigger, for adult. This is an adult size hoverboard, if you will, cart attachment. But I could also come back and do something similar like that if I decide to. So I mean, so many options here that I've been playing with. But this is the one that I'm working on lately, and so it's coming out really nice. It's got almost similar shapes to these other ones. These are a little more elaborate because they have different, a little more complex bends here, and these are approximate more the old-fashioned go-karts, from yesteryear, and that was actually my intent, when I was doing these cars right here with the EMT tubing and maker pipe connectors, just to try to make it work like those many go-karts that are done welded. So I wanted to do this with maker pipe connectors, and I pretty much achieved that, in my CAD drawing, and also on the physical form with respect to this particular shape right here that you're seeing here. Where is that? Right here. And so the other reason why I decided to change to remove this pivoting hoverboard from here and just go with a regular steerable wheel or handlebar here with the linkages with the tie rods here with the C-bracket spindles, is that I want to be able to see if I can turn this into a kit that people can build just buying the connectors. I mean, you wouldn't be buying anything from me directly, but as far as the kit is concerned, you could basically just mimic what I've done here. Just go get yourself some of these maker pipe connectors. Go get yourself some EMT tubing, and all I would have to do is provide exact dimensions on where to bend these things, so that you can achieve pretty similar results as to what I'm achieving here with this particular design here. You can see these right here. These connectors are 45 degrees. They're exact. They're an exact model of the 45-degree connector from Maker Pipe, but now they have these flexible ones or adjustable ones that look pretty similar to what I have here. This is actually one half of that setup right there, and so you have a connector that is pivotable, and you can adjust it to any angle that you want. So it looks something. So you have that part right there that attaches to the bar, and you have this part right here that attaches to the top of that bracket that's able to pivot. So this is the one that is actually supposed to go right there, and I actually have one of these over here, just a half part right there, like that, to be able to support these tubes right here through a bolt right through it. It's working really well. So I have to modify. I have to create that pivotable connector and replace these right here so that it has the proper geometry and angles here, because you can see these bars are angled. So I'll be replacing that, modifying that, not modifying, by creating the connector and replacing these, with the proper ones there. Same thing at the back. This is just a temporary mock-up here, just to get I was trying to get the right proportions and angles on the seats and distance, to the feet here. I'm 5'11", and the distance that I have from this bar right here, the front axle, to the back of the seat is about 44, 40, 43, 42, somewhere around 42, 44 inches. So it allows me to sit comfortably here and put my legs right up against this bar right here. I will probably have some other support here for the feet, and possibly some kind of a brake, mechanical brake, or maybe even an electronic throttle attached, just like a real go-kart. But I've been doing all that control via the handlebar here, via the steering wheel on my other go-karts, because I am using these hoverboard motors, and so all that is electronically controlled. The braking is controlled, the speed is controlled, through throttle, just a throttle, one of those handles that has the 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 potentiometer and whole sensors embedded in there. So I've been doing it that way. So anyway, let's go take a look at what this is looking at now that I have kind of introduced this modification that I'm doing on this, and I'm calling this the Mia Hover Kart. I was going to trademark the name, but unfortunately somebody else took it, so I actually decided not to go that route. And like I said, I don't want to sell these things. I mean, I'm doing this for fun, but I would like to at least see if I can make this simple enough that anybody can build it. As a kit. You go buy the parts yourself. Go buy the EMT tubing. Go to your hardware store, the local. Home Depot, Lowe's, whatever, Menards, in Chicago, and get some EMT 3/4 inch EMT tubing. Get some of these awesome maker pipe connectors. It allows you to do a lot of stuff. And if you get tired of this, you can, the beauty of doing stuff like this with these maker pipe connectors is that you can take it apart. You're not locked to any, that's what has been allowing me to do all these changes in real time really quick. Is because I'm not welding anything. But like I said, I will be welding that ring here for the support of this steering bar right here, so that it rests there, maybe with a collar, stop collar there, a couple of stop collars right here at the bottom, so that this steering bar does not go up and down. It's steady, but I will be welding that to the bottom here. A little welding here. That's the only thing that. Where this differs than my original racing go-kart that I did many years ago is that when I did that racing go-kart based on dimensions and basically inspired by stuff like this, I decided to make even the spindles from maker pipe connectors. And if you see those videos, you'll see how creative I got with these maker pipe connectors. The only problem is that unfortunately, I wasn't able to get the precision that you get with a welded C bracket, a properly welded C bracket that's that is self-contained, with the control arm, just like these, and that's why I favor these. In fact, I made it even simpler than my other recent go-kart that I did, where I'm using a double bar. Where's that drawing? Or I'm using a double bar. Here it is. I made it simpler than this guy right here. There's some other options here. Let's see, where's that double bar? Double bar, it should be right there. Right there's the double bar. And so this one right here, this latest one that I'm talking about, is a lot simpler because it only uses one bar. And the distribution of this these horizontals or these lateral tubes right here at 12 inches. Between a 20-inch bar right here and a 24-inch bar at the rear. The rear is a little bit wider. You have a good distribution of weight here as well, as opposed to having something with these parallels a little bit closer here. So I think this is the way to go, and I think it's going to be a very nice go-kart once it's done. I am painting this red as well, so I'm going to be painting the whole structure today. I have some parts already painted, but I will be completing the paint of these bars right here, these laterals, or longer runs. I guess they could be called. My front bumper, all those things. I do need a couple more of these brackets here. These are called 180-degree brackets. And so I'm going to be ordering some more of these from Maker Pipe Connectors, because I basically ran out. I had a bunch of these things, and because I've been building a few of these go-karts and contraptions, I just ran out of those parts. So I'm going to be building more. I'm going to be buying more of these connectors. Yeah, so the only welded parts, my point was, these C brackets right here that you see there. I have videos on that. That I show the process of that, and kind of as a diary, as I've been saying in my videos. I'm doing this more as a diary, as a record of how I'm doing these things. Just working a little bit at a time, a day by day basis. Sometimes I get a little lazy and tired, and so anytime I don't post the videos because I'm probably tired or working on some other things in my home here that I also need to attend to. But yeah, this is done for fun, and hopefully people that are watching this are also enjoying my videos here. Um, I don't. There are some great videos on some builds, and there are some really crappy videos of people building things. I mean, I've seen people build things with shopping carts. For God's sake, it's like a cage, for the go karts. It's kind of, in my opinion, you can build whatever. I don't like to criticize things that are done properly. But when you start putting, for God's sake, a shopping cart around a frame, a nice frame that should be that should be the focal point of the go kart, you just could totally ruin the concept of a go kart, and just to get views or whatever you're doing it for. It's kind of, in my opinion, it's kind of stupid. It's very, 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 very silly, to do that. I'm sorry that I have to use words like that, but it's a little upsetting when I see people doing things like that. I mean, like I said, you could build whatever you want, but try to keep it. At least try to keep the concept of the go kart. Is a go kart. Go kart is an open frame design. The true nature of the go kart it shouldn't be more than the frame and the proper components to operate it, to drive it, to control it. But when you start adding, cages like a shopping cart on top of that, it just, I just don't understand that mentality, and it bothers me that I have to say something. Things that bother me, I typically say something. I'm known for speaking my mind out. When I see silly things like that, I will talk about those things because it bothers me, and I'm pretty sure some people may agree with me. If you disagree with me, well, tell me why that why you like stuff like that. I'm trying to find out. I just can't understand that. Like I said, that mentality. So anyway, let's go on to the real thing right now. Let me post this video and continue. Okay, so here's the actual physical model here. As I was explaining, I actually made these changes in real time, and then I went into the CAD model and started modifying that. As you can see, I lowered these. I had to unbend some of these tubes here. But in order, when you do that, the only thing is that you're not going to get a nice clean bend anymore, because you're actually forcing the original bend into something that it wasn't meant to be. So I have these little dents here. They came out. I mean, this is not really bad, and it's from my bender. When it grabs it, and it needs to retain itself nice and tight. And I need to force these bends, unbend some of these curves. It creates these dents here. So that's the only part here. You can see it's a little more defined in the back here. It's not gonna go anywhere. It's not gonna break. It's not gonna bend here. And I do plan on putting a brace, some kind of a brace, just a single brace from here to the back axle. This backrest. That's the seat. That's This is actually this was my seat originally for the 6.5 inch wide spacing that I had before, and that was going to be like that. I can still use this right here because this dimension is actually about 12 inches, so I can still use that. But this board is just sitting here as a mock-up here. This will actually be more something like that, so that it sits flush with the sides of the tube, and this will be much shorter. This is it's just a mock-up board here. I need to get a proper board here, a nice board. So anyway, this is the front end already set up, as you can see. And those are the welded C brackets with spindles. that are ready on with the wheels here. And as I was saying, this is where my that cover, that 3D printed cover, is going to go here. And this bolt will have to this actually needs a spacer very similar to this spacer here, which are, just this is actually tubing for water lines for, I guess, for washing machines. You can buy this also at Home Depot. They come in red and blue, for blue for cold and red for hot water. So it's actually good stuff because it's just durable. I think it's polypropylene. It's a super tough material, so it works great as stuff like this. You can also do metal. I didn't have metal, so I use these for now. But I'm actually going to change these to red, so that it matches all the red stuff that I'm going to be painting here. To match these other red parts. This right here is the this is actually what I was talking about, doing the connection here from my steering. This is my steering arm right here, so this will have to be extended out over or under this pipe right here and it's going to go through a part like that. It's going to be probably welded on top or at the bottom at that angle here. The beauty about having this this setup also with these maker pipe connectors is that I can change this whole assembly here. That bar, this connector, and these right here are solid. Meaning that these connectors, it's not like it's not like a connector that's just supported like that, because these maker pipe connectors, they're designed so to hold the pipes like that, and this bolt right here actually does the clamping. But the problem with that is that you can still, with under heavy forces and heavy loads, you can still pivot this even, especially when you put your body weight, So in order to avoid the pivoting of these tubes, what I did is I created a die to do what I call the bow tie pressed end on these connectors. You can see there right there, that geometry that you see at the very end of that tube. It looks like a bow tie, and so that is to allow me to insert the tube all the way in, so that these things are retained there through this bolt, right through the tube itself. And so that's the MIA bow tie pressed ends for EMT tubing, so that you can use it with these maker pipe connectors. And so I've done that here, and I typically do that in critical areas where I want the tube to be retained more permanently to these connectors. So that whole assembly is not going anywhere. However, because this is a clamp here that's clamping this bar right here, this has the possibility of twisting unless I put a bolt right through there and clamp it with that twisting, or if I weld that ring, like I said, for support of this steering axle right here, that'll be a sort of a stop for this to pivot. So this will be really tight right here, so it's going to create a nice solid support here. And once again, the beauty about having something like this, just a clamp, is that I can tilt this to create my caster angle. You can see this has a little bit of caster angle here. If I were to put a